This video we're going to look at similarity. Now, similar shapes are shapes which have the same shape, but they're just different size. So for example, you can see here, this shape is similar to this shape here. They're both pentagons and all angles are the same. So they are regular pentagons, so they must be similar shapes. Other examples of similar shapes would be circles. For example, if I have a circle here and I have a bigger circle, they have both exactly the same shape, but they're just different sizes, so they are what's called similar. Likewise, if I had an equilateral triangle, just draw a very rough equilateral triangle, and another one, they would be similar shapes because all of the angles are the same. They're the same shape, they're just slightly different sizes. The key thing is all corresponding angles are equal and corresponding sides are in the same ratio, i.e. the same scale factor. So for example, if the side on this thing had been 2 and the side on this had been 4, then to get from the small one to the big one, you would just multiply by 2. If we change it a wee bit and say the size on the second one had been 3, then what you would have to do is multiply by 1.5 to get from the small one to the big one. So how you can find your scale factor if you didn't know the scale factor is you can just do the big one divided by the small one. That's if you're going from small to big, or you might go the other way around. You might go from big to small, and the scale factor would be the small one divided by the big one. Okay. So they've said it here, the scale factor is equal to the image length divided by the corresponding object length, and that's very important, the corresponding object length. So here, we'll see what that means. Here, the side 3 becomes side 2. So side 5 becomes side x. So it's 3 goes to 2 and 5 goes to x. So this question says find x. So I'm just going to do this a couple of ways. First way I'm going to do using the scale factor, and I'm going to realize that my side 3 goes to my side 2. So I'll get there by multiplying by 2/3. So my scale factor is equal to 2/3 to get from the big triangle to the small triangle. So then I can say side 5 times the scale factor, which was 2/3, is going to give me x. So 5 times 2/3 would give you 10/3 is equal to x, and 10/3 is the same as 3 and 1/3, and the units are going to be centimeters. The other way of looking at this is by looking at the ratios of the lengths. So let's just have a look to see what I mean here. So this side 2 divided by its corresponding side will be equal to another side, x, divided by its corresponding side. So we can say 2 divided by 3 is equal to x over 5. So this 5 multiplies across, and we'll have 5 times 2 over 3 is equal to x. So similar to what we've just done, 5 times 2/3 is 10/3 is equal to x. Then x, of course, then is 3 and 1/3 centimeters. This next example says determine if these rectangles are similar. So first of all, this 1.5 is a shorter of the sides on the small rectangle, so it has to go to the 6, and this 5.5 then has to go to the 10. So basically what we're going to do is see if they are in the same ratio, and if they are, then we know it's okay, then it's fine, it works, then they are similar rectangles. So I just want to find out what in this one, I'm just going to do what the scale factors are. So we'll just say if 1.5 goes to 6, that means the scale factor is equal to the 6 divided by 1.5, and that works out very nicely to give you 4. And then the 5.5, it goes to 10. So your scale factor is 10 divided by 5.5, and you can see it doesn't work out just as nicely. It's about 1.81. But the important thing is it is not equal to 4, so the scale factors are not the same, so they are not similar shapes. Okay, now we're on to an example much like you would get in an exam. So in this example, it says find the value of x, and it's not maybe obvious that this is a similar triangles problem, but you can imagine here you've got a small triangle here, and you've got a bigger triangle. So you've got two triangles, and I'm just going to go through why they are actually similar triangles. So similar shapes, sorry. So similar shapes, they are similar triangles, but they are similar shapes more importantly at the minute. First of all, both of them have got a right angle. So there's one of our angles is the same. And then this angle, if I extended this line here and extended this line, then you've got a set of parallel lines. So this angle in here is corresponding to this angle here. So this angle and this angle are the same. And also they both share this angle. So you've got all three angles are the same. If all three angles are the same in a triangle, then they are similar triangles. So more importantly in this case, they are similar shapes. So we can use our properties of similar shapes then to find any missing sides. Okay, right, we need to find this side x. I'm going to redraw this thing. I'm going to redraw this with two triangles. So my small triangle, I'll mark in my right angle. There was a 3 centimeters and a 2 centimeters. And my bigger triangle, which is we now know is similar, and its tall side is 6 centimeters, and its horizontal side is 3 plus x, and that's going to be centimeters. So we can clearly see then that the side 2 becomes 6, and we could probably easily work out what the scale factor is to get from 2 centimeters up to 6 centimeters. And then we can get from 3 to 3 plus x by multiplying by the same scale factor. So I think we'll just do this using the scale factor method. So I'm just going to say small to big. So I'm going from the small triangle to the big triangle. So small triangle is 2. And then 2 times what gives you 6. And hopefully you'll realize that 2 times 3 gives you 6. So then the same idea means then we will say from 3 times 3 is going to give me 3 plus x. Sorry, I'll write that out a wee bit differently and just say, use the arrow notation again. So I'll just say, sorry, we'll say 3, the side 3 gets multiplied by 3 to give you 3 plus x. I'm squeezing this in here. And then 3 times 3 just equals 3 plus x. And that's just now an easy equation. So 9 is equal to 3 plus x. And 9 minus 3 is equal to x. And your last line, x is just equal to 6. And just check the units, they are centimeters, so 6 centimeters. Okay, that is us done with just the introduction to similar shapes. In the next video, we're going to look at similar triangles.